This is 2015, number 4, which is our graph analysis problem. Part A asks you to find relative maximums. So what you should look at, since this is a graph of the derivative, you should look for zeros in the derivative. At x equals 1, it's a 0, but it has an even multiplicity, meaning it touches the x-axis, it doesn't go through, which for us should signal this is a point of inflection, not a max or a min, because the derivative doesn't go from positive to negative or negative to positive. What I'm looking at on this graph is that at x equals -2, f prime goes from positive to negative. So f has a max, a relative max there. X equals 4 is not a max because it would be going from negative to positive, which would be a min. And it doesn't continue after 4 anyway. So, okay, so that's part A. Part B asks about concavity. On what open intervals contained in -3 to 4 is the graph of f both concave down and decreasing? So what this means, and then it asks you to give a reason. So the reason can really be just a sentence here, but remember that if f is concave down, in f prime, that means f prime is decreasing and it's negative. So we need to look where f prime is decreasing and negative. So I see from -2 to -1, and from 1 to 3, f prime is decreasing and negative. So f is concave down and decreasing. Okay. Part C asks find the x-coordinates of all the points of inflection for the graph of f. So points of inflection in the derivative look like maxes and mins. Meaning, if you're finding a point of inflection in the function, they look like maxes and mins in the derivative. So I see x equals -1, x equals 1, and x equals 3. And what you can say is that at x equals -1, f prime goes from decreasing to increasing. At x equals 3, f prime goes from decreasing to increasing. At x equals 1, f prime goes from increasing to decreasing. So these 3 values are points of inflection. So you could have combined x equals -1 and x equals 3 into one sentence, but that's okay. Nice to be thorough. So that's how you say that something is a point of inflection. You have to say that the derivative goes from increasing to decreasing or decreasing to increasing. Okay. Part D, of course, is the tricky one. It's asking you, given that f of 1 equals 3, write an expression for f of x that involves an integral. Not an interval. So with these problems where they tell you a value in f, and they want you to write an integral, you have to write an integral kind of in your head, think about like with respect to that point, meaning that my integral will always start with x equals 1 here. So this point, this x value, is where you'll always start the integral, because it's the frame of reference that you're being given. So that means that my integral will go from 1 to something else. Now, we in class talked about x, and maybe you in your class did too. 1 to x. Now, if I use x in the integral, I cannot use x. If I use x in the limits, I cannot use x in the integral. So you can pick any other variable you want. Typically, we pick t. That's convention, but you can pick whatever you want. Now, what I know is that whatever this is, I'm going to add 3 to it, because that's the value of f at 1. So I know that that's kind of my initial value. So I have to add it. It's just like when we did some of those particle motion questions, when you're given the initial distance or the initial velocity, and you have to add it to whatever you find, because the integral won't incorporate that initial value. Okay, so this is my integral. Then they want f of 4. So then I'm going from 1 to 4 of f prime of t dt plus 3. Well, they gave me the integral from 1 to 4. It was 12. So it's 12 plus 3, which is 15. F of negative 2 is a little trickier. Now, really, I don't like the way that in the problem they say that the areas are 9 and 12 respectively. Well, it's 9, but the integral isn't 9. The integral is negative 9. So I don't love the way they say that, because obviously you can't have negative area, but that can be confusing. So what we have to remember is that when we're talking about that integral, it's negative 9. But what I'm going to do is I'm going to write it like this. 3 plus, now I'm still going from 1 to negative 2. 1 to negative 2 of f of prime of t dt. And remember that if I'm going from a positive number and the top number is negative, I take the negative of what the reverse of that would be. So this would actually be 3 minus negative 2 to 1 of f prime of t dt, which for us is 3 minus negative 9, which ends up being 12.